right?
Yes.
What do we do next?
And then the other one is already 1 minus probability of A.
So
We can further factorize it into...
we can fully factorize it. I like that fully factorized term. So now you want to take that out. See, this is where we got our probability of B. From this group and this group lies probability of B. So you factorize them, right? And now, between this group and this group, you can have probability, 1 minus probability of A. Can you see that? So that when you remove probability of A from these two groups, what do you have? 1 minus
Probability of B
crystal K. What do you do next?
equals probability.
Louder, please.
Equals probability of A prime.
Equals probability of
A
A prime times probability of B prime. That's why I said your addition of a complementary property comes last or later. This is it. And this is what you want to prove. So once you're able to show this, the conclusion will be therefore A prime and B prime, yes, are independent. The word also was used, why not? Are also independent events. It requires a lot of thinking, isn't it? That's why I said we should analyze together. Still have some time. Quickly. This one. I want to find probability of D. Any idea? I want to find probability of D. This is what we have, this is what we have, this is what we have. What's the first thing you would do in exam?
Write out probability of D given C.
Probability of D given C,
Equals probability of D intersection C.
Good,
Over probability of C.
good.
And
What do
then,
you hope to get from here? Say that again. We want to find probability of D intersection C from here. And that will be what?
Probability of C.
Probability of
C.
C.
Over 4.
What?
Over 4. Wait.
Anybody else?
Times probability.
Times probability of.
D given
D
C.
given C.
I've warned you with this. So you've already put in the product. If you are putting in the number, why do you want to write probability of C when you could have also said this too?
Like that.
And that is not even a good way to explain a proof. You just want to go straight to the numbers. So this implies probability of D intersection C is equal to, yes, 9 over 20 times 1 over 4, which is equal to 9 over 80. So we can do the same here. Also, probability of D given C complement will be, quickly,
Probability of
D intersection C complement divided by,
probability of C.
so here also, you can cross multiply. Probability of D intersection C complement is equal to probability of D given C complement, probability of C complement. So, what is this?
1 over 5.
1 over 5
Times 1 minus.
times what?
1 minus.
1 minus 9.
So you can write 11 over 20 directly. And that gives us 11 all over 100. This is just analyzing what we have. It doesn't help us yet. Okay? There are many ways. The easiest way I would suggest for you is go to the Venn diagram. Since we are talking about intersection, it means they overlap. They are not mutually exclusive. Isn't it? So our Venn diagram will look like this. So that we have C and we have D. So we assume our cardinality of the whole universal set is 100. So that whatever probability we write will be sufficient for the cardinality of each region. Am I making sense? So our numbers here will denote probability. It doesn't denote the set because we don't know anything about the set. Am I making sense? So let's now insert all this that we have. We have the intersection of D and C, 9/80. Right? We also have the intersection C prime, which means D only, which is what? 11/100. The question is to find probability of D. Is it enough? Is this enough like steps now? How do we now find probability of D? You add them together. So probability of D will simply be the cardinality of this, right? And that will just be 9/80 times 11/100. Whatever you get, DIY. And the next question says, are C and D independent? You know what to do. What would you do? You multiply their probability? Yes? Oh, plus, my bad. It's plus, not times. Thank you. Calista was looking confused, like, oh my God. Oh, what was going on? Did I miss something? No. I can see your face. Does this make sense? Then we do this next thing. Are they independent? Find the product of the two, your result, and this. See if it is the same as this. If it is not, then they are not independent. Why they are not independent? None of your business. Just say, oh, they are not independent. They are criminals. Arrest them. The last one, quickly. We have about 5 minutes before Mr. Long comes here to chisel out. What can be deduced if A or B and A and B, as well as A or B, are independent? Remember, this is A and B, right? The event that A and B occurs, and the event that either A or B occurs. These two events are independent of each other. That's what we want to, that's what this question is about. Okay? For these two events to be independent, what must happen? That's the first thing we have to talk about. For A intersection B and A union B to be independent events, what must happen? Yes? Louder. A intersection B. Say that again. This, anybody, means what? I want to be sure that everybody understands what Karen has said. What does this statement imply? A and B are independent. But is that what the question is talking about? We know nothing about the independence of A and B as at now. The only thing the statement is telling us is that A and B, as well as A or B, are independent things. A separately, B separately, we don't know their connection for now. So you cannot assume. Yes. What does this mean?
Probability of A intersection.
Probability of A intersection B.
Intersection.
Speak louder.
Intersection.
Intersection.
A union B.
So you treat them as one entity. A union B.
Equals.
So that's like your X intersection Y. So it must be equal to what?
Probability.
Everybody? Probability of, except Lillian. Probability of A intersection B, times probability of, good. Okay, So that is like your x, and this is like your y, if that makes it easier. It says, what can be deduced? Please focus, stop chit-chatting. What can be deduced if this and this are independent? You start from what you know. Then you continue to analyze it. Okay, so if this happened, then it means this happened. Then it means this happened. And the last line is what you can deduce. Understand? Because this looks complicated, I'm going to bring it out now, so that I can simplify this. Okay? A intersection B intersection A union B. Okay, I'm going to use something that might be strange to some of us. It's called distributive property. I might have mentioned it in the past. This is why there's need for stretching in Form 3 and Form 4. No, not that kind of stretching. I mean, stretching you beyond your syllabus. In set theory, we have something called, apart from the De Morgan's law, we have some other property. For example, associative property, a commutative property tells you A intersection B is the same as B intersection A. It means it doesn't matter which order, you get the same thing. And the same with union, but that's not the point here. Associative property looks like the expansion of brackets. So if you have A, B plus C, remember this is times. This is going to be A times B plus A times C. Is that not? So same way in sets, if you have X union Y intersection Z, so this is like your A times something. I'm definitely going to put that. So that will be X union Y. Can you see? Then intersection X union Z. So something like this. X union, so it's like X multiply Y, separated by this, then X also multiplies Z, something like that. So that we are going to apply here. So this is going to go with this, then this again with this, the two results separated by union. Am I making sense, please? So this is going to be A intersection B intersection A. Do you agree? Talk to me, please. Union A intersection B intersection B. Okay? This is like my X and this is like my Y, Z. So it's like X, Y, then X, Z. Okay? So this is like a plus. This is like a times. So X is multiplying Y added by X is multiplying Z. Something like that. Karen, are you lost? So removing the brackets, because they are the same operation, and remove the bracket. A intersection B intersection A union A intersection B intersection B. What is A intersection B intersection A? Quickly.
A intersection B.
Just A intersection B. What about this?
A intersection.
So what is A intersection B union A intersection B?
Intersection B.
So all this nonsense is actually A intersection. Alright? As a result of this, so if you call this 1, then you can say 1 becomes what? Quickly. Probability of A intersection B equals to probability of A intersection B times probability of A union B. Okay? So you can see there's something common. Can I divide both sides and conclude that probability of A union B is 1? Yes? Talk to me, please. No. You can tell me why it's wrong to divide.
It could be 0.
It could be 0. What if the probability of A intersection B? We know nothing about A and B. What if A and B are mutually exclusive events? And the probability of the intersection is 0. We know nothing about A and B, so you cannot impose your rule because it makes it easier. If you cannot divide in quadratic equation, you factorize. Remember that? You have 2x is equal to x. You cannot divide just straight away because you know nothing about x. So rather you say 2x minus x is equal to 0. Then you say x bracket x minus, look, 2x, no wait. No. I mean squared, like this. Then you can say, oh, x bracket 2 minus x, something like this. So same way here. You can bring this here or you can bring that there, your choice. So if I say probability, so this implies probability of A intersection B minus probability of A intersection B times probability of A union B is equal to 0. This implies probability of A intersection B. What do I get quickly? 1 minus probability of is equal to, if the product of these two is 0, either probability of A intersection B is equal to 0 or probability of, no, or what? 1 minus probability of A union B is equal to. So what we can deduce is that either probability of A intersection B is equal to 0 or probability of A union B is equal to what? 1. That's what we can deduce. So if I ask you to comment, what is the comment here? A and B are? Say that again? Mutually exclusive. And the entire A and B is the universal set. It means the outside one does not exist. Understand? So this is what we can deduce. Thank you.